Welcome back, everybody, to another live stream repair. We've got two first generation Apple HomePods to fix up today. First one from Mark with, you guessed it, no power. And the second one from Matt, also with no power. A very common issue with this particular device. Matt in particular, actually, I believe I think it was CNBC, they recently posted an article, actually, about their HomePod, essentially calling it a doorstop, and, had a lot of people reaching out to me, telling me I should reach out to them, letting them know I can get it fixed. He let me know that he had, of course, plenty of people telling him to reach out to me as well, which I thought was pretty cool. So here we are. We've got Mark and Matt's HomePod to get fixed up. Let's get started. Here is Mark's HomePod. We've already taken out the power cable. It's really easy. You just grab it and yank it out. And we've got here a known good power cable. So the first thing we're going to do is check and confirm our symptoms. Make sure that it wasn't anything like the power cable, which it almost never is, but we've also got our cable connected to this kilowatt meter here so we can see if and how much power it's pulling from the wall. Yep, HomePod is definitely not doing anything, and we are pulling 6 watts of power from the wall. So it is doing something in there, and based on that and our previous experience with many of these, I've already got a great guess as to what's going on. And if you've watched any of our prior repairs, you probably know what's going to happen too, but let's get this open and find out what is causing this thing from powering on. Of course, we're starting by getting that plastic top off. We're keeping our tool nice and level with that top so it doesn't scratch it up. And we're just going a few times around until it pops off all on its own. So now that we've worked up a sweat, we'll go ahead and hydrate ourselves. Oh boy. Cheers. Let's get this display out now. We'll be using the T6 Torx bit for the entire HomePod. Just 4 of them up top here. And then back to our Jimmy tool, we're going to pry that display out. Making sure that we get under both of those layers. We do not want to get underneath this plastic layer and separate this plastic from the PCB. We want to get under that PCB. And then also we don't want to actually go around this with our metal tool. We want to use a plastic tool. Slide that under. We can take our metal one out, and this will be what we actually use to pry this up. That way we don't scratch up our PCB on the bottom here. And the reason why we don't want to separate this plastic layer from this PCB is 2 reasons really. One, you're most likely using a metal tool, which you shouldn't. But if you are, you will scratch this PCB up enough to damage it and most likely render it useless. 2, there is an ambient light sensor on this side of the board. You see right there, that shiny little chip. People very often will accidentally put their tool in between these layers when they shouldn't. And it'll go too far and slice that sensor right off the board. That sensor itself, if you slice it off the board by itself, is not a critical problem. The only thing that happens is you lose your automatic brightness. So that doesn't mean the display won't turn off. That just means whenever the display is on, it's just going to be at full brightness. So not the end of the world to most people. And I tell that to people who try to buy a replacement display from me. And I'm like, by the way, if you're just buying this because you broke the ambient light sensor off and you don't need automatic brightness, which honestly you don't, you're perfectly fine. You don't need to buy a newer display and replace this. It's pretty much a waste of money. Okay, now we've got our logic board out. We're going to get some rubbing alcohol. I need to get more rubbing alcohol. Careful, easy, careful, easy. Only a little mess. Okay, the mess is getting bigger. It's just rubbing alcohol, it'll dry right up. So we're going to take some of that and we're going to drip that right into the side and swirl it around. This will make a little more sense after these next few steps, and I'll point it out. But for now, let's get this ribbon cable detached from our basket. We don't want to rip that thing when we go to pry this basket up. And we've got some covers for these screws holding said basket down, so let's expose those and get them taken out. Is she awake? Mom's in there with her, so. So this is the part where we pry this basket up. And without that rubbing alcohol that we dripped in there earlier, this would be a lot more difficult. But we can almost pretty much pry this up with just our bare hands, and there you go. The most unfixable device in the world, defeated in less than 10 minutes. subwoofer is in fantastic shape. Let's get the rest of our plastic out of the way so we can get to the problem board. This is that glue that we defeated with fat rubbing alcohol. It's completely unnecessary. All it does is serves as an anti-repair barrier. And just like that, she's back asleep. I was reading that it's fairly normal for your baby to like wiggle around and even cry briefly while they're sleeping. It's best not to always rush right to them whenever they start crying. Give it a sec to see if they're sleeping or not. It seems to work really well. More often than not, she ends up getting an extra half an hour of sleep. And then she wakes up in a great mood. As opposed to, before, whenever we would rush to her and pick her up every single time she cried. As soon as she started crying, often, she wouldn't calm down once we got her, because, that would end up waking her up, and we didn't realize while she was, crying a little bit that, sometimes she's just doing it in her sleep, I guess. And that's apparently a normal thing for babies. Okay. Here's the amplifier board. Here's the power supply. And our problem, despite what you may think, has nothing to do with the power supply. If we look at our amplifier up close, we can see right here our friend, the Schottky diode. This one has a date code of 1748K on it, and that is significant because these HomePods with no power in them continue to have the same date codes on these diodes, 1746K or 1748K. And then all the hundreds of HomePods that we've had in for other issues like bass issues or death farts or whatever that have no power issues, they power on just fine. We've got much older and newer diodes in those than this. So what it seems like, of course, is again that there's just a bad batch of these diodes floating around out there. So we're going to go ahead and replace this with a new one, a brand new one. This is a 5 amp. We're replacing it with a 7 amp diode. I don't personally think that it has anything to do with the spec of the part itself, necessarily. If it was, we would see other date codes failing and causing the same issues, and that's just not the case. We've got hundreds of these, totaling thousands overall. and the pattern continues. But that said, we are replacing it with technically a beefier version of this diode, simply because it's actually cheaper. You know, supply and demand. And that's all there is to it. We'll give this a sec to cool off and we'll test it out. Sorry about that. Whacked my hand on it. Okay, is that cool enough? Yes, it is. We're gonna put this back together at the most basic level, just enough to get it to turn on. So we can make sure that it works just fine. My phone's blowing up. Alright, we're good. And here we go. We've got power. Let's get our multimeter up so we can check its DC offset. Okay, so we've got a good offset, we've got great sounding bass. This one is ready to reassemble. So we'll go ahead and do that now. Just a few screws in a few minutes. Okay, the amp is fully secured. We can start making this look like a HomePod again. Nice and sealed. Oh, and yeah, at this point, the HomePod is completely sealed off. Anything that you mess up from here forward basically won't have any effect on how the HomePod sounds because it's entirely sealed from here on. Now, of course, with the exception of this, if you don't stick this back to the bottom of this, then it's gonna flap around with the subwoofer, of course, but gasket speaking and glue speaking, there's no reason they glued this down. No good reason, at least, because all the seal is done further down below. And if it was supposed to act as some sort of secondary or failover gasket, then they did an awful job doing it in practice, because we've seen far too many of these where the glue is only put halfway on, and well, if it was the only gasket or the failover, it wouldn't do anything. So it's definitely not doing us any favors being there. But now that it's gone, if and or when somebody wants to open this up again in the future, it'll be significantly easier for them to do so without it affecting the sound. Okay, so we're going to stick this back to the bottom of the basket so it doesn't rattle around. Just like that. You see, now it's not going anywhere once we put our logic board back in. Get that frame settled into place. And we'll start dressing it up. Hey, Top G. Not sure if we've ever spoken before. If you have, I unfortunately don't recall what may have been your problem or what you have tried, but I'm always happy to try to help out one way or another. If you want to shoot me an email with pictures of what you've got, what you think is going on, or if you want to just send in your board, we can probably clean it up for you, and it'll be a lot cheaper than the repair on a full HomePod. But either way, though, we wanna see you get a working HomePod again. Let's get this display back on. We're almost done with this one. I am also working on a few different options for like a drop-in replacement amplifier for these. The upside is you completely ditch any reliance on Apple, and you still have AirPlay, Bluetooth. We'll get auxiliary in working. The downside, of course, is we wouldn't have Siri, but we could probably get some sort of HomeKit integration working on it. That wouldn't be too difficult. The point really is we want to ditch having to rely on Apple's smarts, and that means well, the easiest way is replacing the amplifier entirely. And I've come up with a few good ideas. Underneath the rubber base here, there are pogo pins, so we do have multiple options to connect to this thing. Or I should say repurpose those bottom pins for some extra stuff that people may want to do with these. But Apple's not gonna, they're not gonna be supported forever. And especially the ones where the logic boards get bricked and there's no way to restore the software anymore. Even still, it would be really nice to be able to put something in the HomePod that lets you continue using it as a wireless or, hell, wired speaker. It'll take us time, but we've got time. Do we have a working HomePod? Drum roll, please.
I'm having trouble connecting to the internet. I'm having trouble connecting to the internet.
Beautiful. It sounds good. Our volume buttons light up nice and evenly. So Mark's HomePod is fixed up and ready to go. That leaves us with Matthew here. Who has the exact same issue. So, let's let Matt know that we're getting started on their HomePod here, and then we'll get started on it. Okay. I tried replacing the diode before, but I think my heat temp was too hot. Melted a couple of parts around the diode. Well, unless you have a fairly decent hot air gun, which I'll admit, mine is literally the cheapest one you can get on Amazon. I doubt that your heat gun was too hot. We run ours at the highest it'll go, 500 degrees Celsius. More likely, you probably used too much heat for too long. Probably, a combination of heat, but also, of course, you probably held it there for too long. What you can do if you're having problems getting the diode off is stop and let the board cool down a little bit first, and then go ahead and pick it up and heat up the bottom of the board where that diode is for a good 30 to 45 seconds. And that's going to help heat soak that area of the board, because that hole, there's a lot of copper there. It's acting as a big heat sink and pulling all that heat away. So that's helped a lot of people get that diode off when they've had problems. Melting a couple of parts around the diode. I would be interested to see pictures or see that board here in person also to try to fix it up for you. We've got plenty of parts boards to replace as much as we need to, so long as the board itself isn't too damaged, or you haven't gone through multiple layers and connected multiple planes to short it to ground. Then it should be repairable. But we're willing to take on a lot of challenges here, so I'd be curious if it's feasible. Shoot me an email and with some photos of what you got and where you are, where you're located roughly, and we'll see if we can't help you out. Anyways, we've got Matt's first gen HomePod here, like we were talking about at the beginning of the stream. Matt is a writer / editor for NBC, and he recently posted an article about his doorstop of a HomePod that recently died on him, and Apple completely leaving him in the cold. So, funny enough, I was not the first person to reach out to Matt. I had tons of people reaching out to me, telling me I should reach out to Matt. Matt, as soon as I reached out to him, he told me, of course, he had a bunch of people reaching out to him, telling him to reach out to me. So by the time we actually connected, we were both pretty much on the same page already. So here it is. We've got his HomePod, and we're going to show you how it's done. First things first, of course, we've got a known good power cable connected to our kilowatt meter over here. This is going to help make sure, that there isn't anything wrong with their power cable, which, again, we pretty much never see any problems with people's power cables. But it'll also show us how much power it's drawing, which gives us a big hint as to what may be going on inside. So it's not doing anything, at least here. On our kilowatt, we are pulling 4 watts. So, what that tells us is we do not have a blown fuse. If it was a blown fuse, power wouldn't be flowing through and we wouldn't have any power draw. And based on how much power we are drawing, 4 watts, we've seen enough of these to know that that is most likely the same diode that you saw us fix just a few minutes ago. And roughly 70 to 90% of the repairs that you see here on the channel. So it's really unfortunate that, if I've only, I'm just one guy in America, and I'm charging so much for these repairs as it is, and I've still personally gotten more than 1,000 HomePods in and out the past year and a half-ish to fix up. I cannot imagine how many are actually out there with this same faulty diode waiting to fail for people, and or all the HomePods that have failed that people just threw away because they didn't want to deal with it, or they thought their only option was going through Apple for repair. Okay. We've got our display and our logic board out now. We're going to grab our rubbing alcohol and drip that in there. Swirl it around. And if you haven't seen any of our prior repairs, that will make a lot more sense after these next few steps. Get that ribbon cable detached. Because when we pry this basket up, this is attached to that basket and we don't want to rip this. That would not be fun. So we're going to uncover these screws around this basket here so we can take those out. One more. And here's where that rubbing alcohol makes more sense. We're going to take our flathead and we're going to stick it in between the subwoofer and the top basket. And we're going to pry this piece up. And having dripped that alcohol in there beforehand, it's worked its way through that stupid useless glue that's in there. And just like that, with pretty much zero effort, we've gotten past the biggest barrier. All that's left is to get our subwoofer out of the way, and we'll be inside. Hello! Glad you could make it to the stream. And I am, of course, always happy to save this stuff, or anything for that matter. Gotta sniff the subwoofer, make sure it's not roasted, you know? Smells fantastic. Looks fantastic, feels fantastic, no concerns there. Anyways, that's right. Wasting our environment. That's one of our biggest reasons why we do this for everybody, because it bothers me so much that it's such a cheap and easy, well, easy is relative, but such a cheap and easy fix. And there were already so many resources put into making these things, and then people spent so much money on them just to die over a $1 diode. And what bothers me even more is if you go the Apple replacement route, they don't do anything with the old ones other than break them down for their raw materials. It just seems like such an inefficient, I don't know. And what bugs me even more is how much Apple spent on making these. It costs Apple $249 per unit to manufacture and get to your door. So if you think about it, at best they were only making $100 on each HomePod. At worst, $50 or less. So they already have very little incentive to provide much support for these. It's shocking that they still function software-wise. Which is why I'm trying to get on top of designing a drop-in replacement amplifier so that when Apple does eventually kill off being able to use these as at the very least as smart speakers or just a dumb speaker, you'll be able to drop in your own replacement amplifier, completely ditch Siri, and you'll still have AirPlay, you'll gain Bluetooth, and no more worrying about software updates that break your HomePod with blinking volume buttons, no more worrying about DC offset or death farts. It'll just work. So I'm planning on, like I said, a drop-in replacement amplifier that ditches relying on anything Apple, and also coming up with a design so if you want to go completely passive, if you want to wire your HomePod into your own external amplifier and just use it as a purely passive speaker, that is entirely possible. They've given us 2 different ways to get connections in and out and power in and out of this thing while keeping a seal. But anyways, enough of La La Land here. Back to reality. For now, we've got a problem to take care of. And it is not on our power supply, it's not on our display, it's not on our logic board. It's on the amplifier. You might be wondering, like, okay, what the heck? If this problem is on the amplifier, why does the whole HomePod stop powering on? The reason, I'll show you. So, this is a power cable that I took out of another HomePod. You can see here, we've got the same connector. So, that, if you recognize, is what the HomePod power cable plugs into. So from there, it goes into the HomePod, and this plugs into your power supply. From there, your power supply plugs into your amplifier board via this connector right here, corresponding to a connector on the bottom of the power supply right here. And they just plug in like so. And then you've got your logic board and display. And these get their power not straight from the power supply. Here's the problem. They get their power and everything through the amplifier. Just like that. And that's how it looks inside of the HomePod if there was nothing else in the HomePod. Invisible HomePod. So what happens is, let's go ahead and get up close to this amplifier and see why it stops working and supplying power to the logic board. Up close, we can see right here an S560 Schottky barrier diode. Underneath that, it's got 1748K printed on it. That 1748K indicates the date code, or essentially when this diode was manufactured. And just to paint the picture for you, again, we've seen hundreds and thousands of these diodes now, and the ones that consistently fail are within the date codes 1746K and 1748K. And then all the other diodes that we've seen out there, much older, much newer, close to this but not exactly this, all of those continue to work just fine. They never fail. They never have any problems. So we think there at Diodes Incorporated, during, the year 2017, week 46 and week 48 of 2017. They must have been doing something funny at the factory because these diodes are not holding up. So what we're going to do is we're going to go ahead and replace this with a brand new diode. That in and of itself, if we even use the same exact spec as this old one, if we replace it with a new one, is going to completely prevent the same problem from happening again. In addition to that, though, we are using technically a stronger diode for this replacement. So I don't see it as necessary at all, but it's a good little extra bit of insurance, and it happens that the beefier diode is cheaper. So why not? Now, if this was like a fuse, obviously we wouldn't want to replace it with a beefier fuse just because it's cheaper. Because then, your fuse isn't protecting and stopping the flow of power when it's designed to. It's letting much more through. And there's, you want your fuse to blow when it reaches a certain amount of power. But for our little friend in particular here, it is perfectly good to upgrade this with a bigger one. Bigger isn't always better. There we go. Let's grab a brand new diode. And this one you can see has a date code of 2223K. So that basically means this was manufactured in week 23 of 2022. That is, relatively speaking, brand new. But age has nothing to do with this failure. These diodes are popping purely because of some sort of quality control issue with them. I'm going to turn on the fumigator. It'll get just a little noisy. We're going to tin our iron. Tin our new diode. And we're gonna go to town. What's cool is we don't even need to have this perfectly centered. As long as nothing's touching anything that it shouldn't be touching, the flow of solder will do the hard work and line it up for us. So we'll go ahead and start heating this up. Once we start seeing that solder melt, we'll poke that diode a few times just gently to help make it nice and centered. And that'll be it. You can see it starting to melt and center itself. We don't even need to do anything, but we're going to go ahead and poke it. And that's it. If you want, it's totally okay for you to press and hold down on it until it cools off. Doesn't make a difference in my opinion. And then we're gonna give it the old air cool for just a few seconds. And let's test this out, see if we did good enough. Do we know what we're doing? We will find out. We're just putting enough in here to hold it together and function. We want to sanity check our work and also make sure there isn't anything else wrong hiding in this HomePod. We do quite often see other issues along with the no power. Not that the no power issue causes other issues, it's pretty isolated, but it's pretty common for HomePods to have more than one issue going on. Okay, and then also very important, we're going to plug in our test woofer here. If you see on the bottom right hand corner of the screen the number in red, that is a multimeter that is connected to our subwoofer's input in DC voltage mode, and you can see every time I stab the subwoofer that number fluctuates. So what we're doing here is we're not only checking to make sure that this turns on and sounds fine, we're checking to make sure that its filters are in good condition, or in other words, that it doesn't have too much DC offset. More than 200 millivolts of DC offset is enough to cause problems and death farts, but we shoot for a more aggressive 50 millivolt target to prevent problems. So let's give this some brains, and let's give us some power, see if we got it. And there we go. We've got power, so we'll just wait for this to finish booting up, listen to the setup tone and make sure that sounds good and its offset is less than 50. Oh. Okay. So this does need new filters. It's just barely above that threshold, but it is enough to make me concerned. So I'll go ahead and talk a little bit more about what we're doing here, what we're talking about. So your analog audio signal is alternating current, not direct current. It's AC, not DC. The signal going into your speaker should not have any DC voltage in it, because an alternating current is going to make your subwoofer move in and back out and then return back to the center in equal amount. A DC voltage is going to make the subwoofer speaker move in or out, and it's going to hold it there. It's going to essentially force an unnatural middle, and what that basically does is it's basically like pushing the brake pedal down at the same time as the gas pedal in your car. You're making everything work much harder than it needs to. For one, the natural movement of the subwoofer is what cools it down and keeps it from getting too hot. So with that DC voltage holding it and putting it under a constant load without giving it a chance to move is going to cook it very fast. And you can see on this old subwoofer that had that problem, that coil in there is nice and charred black. And the reason why this tends to happen is on the amplifier there are capacitors that are supposed to filter this unwanted DC voltage from your audio signal as it passes through the amplifier and goes into your subwoofer. Problem is, well, there's actually a few problems. Primarily, using MLCC ceramic capacitors for your DC filtering without any sort of redundancy, kind of silly to me. The HomePods amp has 4 of these filters. They are these 4 big brown ones right here. The problem is the way that they connected them all together without any sort of failover. It only takes one of these 4 to fail to bring the whole thing down. The other thing is these, ceramic capacitors naturally decay over time. Naturally, they're going to get worse at filtering this unwanted DC voltage. It's basically how they're built. They're basically crystalline structures, and over time, as they get used, those crystalline structures start to put it simply, break down. You can technically recondition them by bringing them up to a certain temperature, which will reset the crystalline structure and bring them back into spec, but we prefer to replace them, replace the whole set of 4 with brand new ones of good quality that we know. We know they're chef's kiss. So we don't want to mix and match filters. We don't want to even try to guess which one of these 4 are bad, because it wouldn't do us any good. We're going to replace all 4 of them and keep them matched up. It is unfortunate that, if one of the 4 fails, the whole thing starts to take a poop, but there's only so much you can do, and in this case, we can replace them with good ones. It's kind of like your car filter. Like, it eventually is going to need to be replaced again. Good news is, once they're replaced, you shouldn't need to worry about them again for a very long time. We're talking years and years and years. The ones that Apple used seem pretty hit or miss. We've seen plenty of examples where they're perfectly fine, less than 10 millivolts of offset, which is excellent. That's what we want with fresh caps. We want less than 10 millivolts. So we don't jump on replacing these filters inside of every single HomePod we get. We tend to only replace them when we have a good reason to. Because honestly, I think they probably used. Usually they used decent caps here, you'd think. Alright, why aren't these coming off? There we go. Okay, we're gonna put some flux on our board. And some fresh solder. And new filters, here we come. So, we fixed the no power issue. And you might be wondering, well, it sounded like it worked fine. Looked like it worked fine. Why is he still replacing these capacitors here? Because they are showing signs of starting to fail. They'll start, they'll stop filtering a little bit of DC voltage, and over time they'll get worse and worse. They don't get better, it gets worse. It never gets better. And once that gets really bad, it'll start to death fart on you. And of course fry your subwoofer. And keep in mind, this is putting extra load on your subwoofer. Where's the power for that load coming from? Your amplifier. So quite often your amplifier will blow up. A few other components near where the subwoofer plugs in will blow up, in addition to the subwoofer. It's not a fun time. So whenever these no power HomePods come in and they end up, surprise, needing new filters too, because if we don't replace them, we're going to send the HomePod back, and a few months later they're going to be emailing us because it started having death farts. We don't charge people extra for this, if it's especially when it's a surprise like this. We've already got it. It's already here. We've got it apart. What's a couple extra minutes and $1 or $2 in more components? Sure, it's a little more of a risk because we could dislodge something, we could break something trying to fix this extra crap, but I think it pays off in the long run because aside from the ones that were self-inflicted, we haven't had anybody send their HomePod back to us for like death farts or power issues. Once they come through us and they get fixed, they're done. They're good. We want to keep it that way. Cause let's say even if the person was perfectly fine with shipping it back and forth a few times so that we could eventually get it right, Wasn't the whole point of this to save money and save the environment? We're kind of shitting things up by shipping it back and forth a bunch of times, don't you think? Yeah. Well, anyways, point is, do it right the first time. Use your intuition. Okay, so obviously we're not expecting any problems with power. We already got that fixed. What we're looking for is that offset. We want that to be hopefully less than 50, ideally less than 10. Look at that. The closer to 0, the better. That's something I forgot to mention. So with DC offset, it doesn't matter whether it's positive 200 millivolts or negative 200 millivolts. The only difference that makes is whether, the subwoofer sits like this or this. 200 millivolts positive or 200 millivolts negative are both equally destructive and bad for your audio system. What matters is how close to 0 you are. You want to be as close to 0 as possible because that's the middle, that's the neutral. That's going to be as close to the natural resting position of the subwoofer. It's going to put the amplifier under the least amount of quiescent load. If you want to know more about DC offset, it's kind of interesting if you're at all an audio nerd to look into, because I thought I was a fair bit of an audio nerd. And then I got into HomePods, and I learned, I funny enough, before fixing HomePods, I didn't even know your analog audio was an AC signal. I always thought, intuitively, you've got a positive and a negative connection on the back of your speakers, so you'd think that's DC. Everything with DC is labeled positive and negative. Everything with AC has a live, neutral, and ground. But with audio, it's different. Your audio is an AC signal. It's an alternating current, not a direct current. So that's something that I learned when digging into the HomePod's problems and trying to figure out the source of these death farts, and what DC offset even is, and how you would even approach troubleshooting or trying to fix that. Funny story on how I actually cracked the repair on death farts, because prior to me getting into this, everybody thought death farts was like the death sentence for HomePods. That's why it's called death farts. If you had them, it was game over for your HomePod. Throw it in the trash. Nobody knew how to fix it. So I was doing a lot of research on DC offset. And what causes it. And it turns out, one blog post I came across said, DC offset will get worse with heat. So I was like, okay, if it gets worse with heat, I should be able to take my heat gun and move around the board until I see that offset jump right up. And I'll know at least the general area of the board where the problem is once I see that offset spike. Sure enough, that led us to that area with those big 4 brown capacitors. And once I got to that area, obviously a heat gun is too wide of an area to really focus on, so I would take my plastic pick, since it's non-conductive, and I would get my plastic really hot, and I would touch around the board and see which component reacted the most to that offset. And that's when we found those filters. It was like top 10 best moments of my life when I found that. And not only found it, but replaced those capacitors with new ones. And like the problem went away. I fixed death farts. I want that on my grave. I solved HomePod death farts. And I also fixed a couple thousand HomePods too. No big deal. Well, and that's just what we've had through our hands too. Like, I've had a lot of people emailing me saying like, hey, thanks, nothing else other than just saying thanks for putting the info out there. I was able to fix my HomePod thanks to you. I have zero clue how many people overall have fixed their own HomePods because of all this. It would be easy for me to believe that there's, for every one person that's willing to send their HomePod in to me to get fixed and pay for the repair, there's easily 10 more people out there that have at least tried to take their own apart and fix it. And at least half of those people that have managed to get them working again. Still really sad to think about how many of these that are actually out there blowing up on people, and they've just got, they're being told by Apple there's no option other than to replace it. Who's surprised? And at the end of the day, you're not going to stop buying their crap. I'm not going to stop buying their crap. it is what it is. Maybe something will change. Like, I'm not just some guy sitting here trying to scrape a bunch of money off everybody off a quick and easy repair. Like, I personally really enjoy these HomePods. Like, as a product, I've got 40-ish online at the moment in my house. About 15 of them in my living room. For what it is, I still stand by it. I've said it since we started doing these repairs, and I still stand by it. This is the best speaker that you can get for what it is, for its size, and for its price. You cannot beat it. People keep bringing up like the Sonos stuff and the Bose stuff, and none of their stuff comes in this size or smaller with this much performance, with a 360-degree surround sound, and this good of a room correction. Like, there's just... Yeah, you've got like the Sonos 5 or whatever it is, but that's a big sucker. It's like 4 times bigger than the HomePod, and not just that, it's not omnidirectional. You have to think about where you're gonna place it and where you're gonna point it. The HomePod, it's the best sounding speaker in the worst setup room ever. So it's really frustrating to see Apple drop the ball from so many different angles on this. They spent so much money on them, so why just... And then the customer spent so much money on it, so why just onto them? The HomePod's starting to look like a HomePod again. I mean, there's nothing stopping you from still using it as a doorstop. It'll just be a smart doorstop with an attitude. Not sure if you got used to using it. Excuse me. 1 second. I'm dying. I don't have any water. Mistakes were made. That's okay, we're almost done here. Oh, if you're wondering what this is, that's my brain. It's my brain.exe not responding. Trying to think of what I'm supposed to be doing next. My wife calls them piano fingers. Ooh, story time. It's a quick short story. Don't worry. Did someone knock? No. Thought I heard someone knock.
Here's Hip Hop Station.
You stop that. You stop that. Right, story time. I forgot what the story was. Oh no. It was a good story too. And it just completely escaped my mind. You'll just have to subscribe and watch all of our videos and repairs, and maybe you'll catch the story if I remember it. Let's get this display screwed in. We're almost done. Alright, this took a little longer than it normally does, but we don't normally have this many people watching, so I thought you guys would appreciate me breaking down what we're doing a little more. Normally it only takes 20-30 minutes for us to cruise through one of these, but yeah, she's being good. So we've got the time. All right. Plugged into power. Drum roll, please.
I'm having trouble connecting to the internet.
Aren't we all?
I'm having trouble.
Sounds good. Volume buttons light up nice and even, so we got the top stuck on nice and centered. We'll leave this, as we do with all of our repairs, plugged in overnight to make sure it doesn't have any other problems, but for all intents and purposes, and from what we can tell here and now, this and everything else that we've got today is all fixed up. 1 second. Oh man, I need some water. Alright, let's wrap this up. HomePods are not the only thing I fix here. If you go to our channel, you can check out our things that aren't HomePods playlist, and we've got a few other fun repairs like a Bose Wave CD player. What else? Go check out the playlist. We've got some fun stuff in there. And we're always looking for more stuff to repair. If you've got something broken that you're trying to get fixed up, check out my website, nixfix.com. We've got our contact info up there, and we may just be the shop that'll fix what no other shop wants to take. If you've got a HomePod that you're trying to fix up for yourself, I've got plenty of info for you to do that yourself, including how to do it, the tools, and the parts that you need to do it all. Again, on my website, nixfix.com, you'll head over to the Common Issues section. Last but not least, if you want to buy some parts for your HomePod or a refurbished HomePod, it comes with our 12-month warranty. We promise nothing will go wrong with it, and if it does, we'll fix it up for you. We've got all that up for sale on our website as well. So, hope you all enjoyed this live stream repair, and I hope to see your broken junk soon. Goodbye!